Welcome to the session on how to supercharge your test framework. My name is Andrew Krug. I do a bunch of stuff. That's what that slide's supposed to go over. So to start things off, I want to ask the basic question. What is the purpose of a test framework? What are like some of the core features of why you would have a test framework in place? The test framework is going to help you make maintainable, reliable tests. And those are the core things that you're looking for in your test framework. This particular fast is not in particular to it being fast running tests, but the test framework shouldn't be in your way of doing what you need it to do. So this is talking about speed of delivery, right? How long does it take you to write a new test? Does it take you minutes? Does it take you days? Does it take you weeks? Did you go on vacation and it's still there? That's probably not good at that point. So the framework should be there to support your endeavors and support all the different aspects you're doing, and then stay out of the way for the most part. So how is that different than any other framework that developers use? Cake PHP, CodeIgniter, those are PH ones, Xpanxion, Vue, React, Svelte, XYZ, it doesn't matter. There is no difference, right? You're using a framework because it makes you deliver features faster. The framework itself is maintained and easy to maintain, easy to add new features, which then also makes it reliable. Of course, there is one key difference, is that the goal of the test framework. The companies that have really good test frameworks in place, they are able enough to deliver features faster, which is the core of your business, deliver features faster and improve customer experience. And if you have a really good test framework in place that lets you do what you need to do and it increases the velocity of the developers, that is good for your bottom line. Test frameworks are obviously building tests, not a product, not an application. So to talk about a slightly higher level, just temporarily, applications are built off of each other, right? You add login, you add authentication, you add features, you add feature flags for different groups of users, whatever. It's all building on one core thing. Whereas test frameworks, on the other hand, you want to build tests. And tests are very particular little beasts. And they're essentially their own little miniature application that does one thing and one thing well. And it's execute a test. That's all it's supposed to do. So the framework is a bit different because it has to support building a ton of little applications all at once. So far, everybody's with me? Awesome. Now, I'm going to talk about some core framework features, nothing spectacular about anything, and global things that they should have. I'll go with that. My recommendation is to use already pre-made frameworks that are out there. Somebody in here made one. I don't know what it's called. I know it's Pylenium. I'm messing with them a little bit. Boa Constrictor is another one. Selenium Base is another one. WebDriver IO is another test framework that you can use. I recommend that you use one of those because they already have a lot of these core features already built in, so you don't have to reinvent the wheel. I will concede, though, building a bespoke custom framework is fun. It is also very time-consuming. So obviously there's tests, which I'll go into much more detail real soon. Any libraries that you use with your test framework, you always want to wrap them. So in case any of the underlying APIs change or you change how you implement it, you can easily update them all. The biggest one was when Google switched from Selenium RC. Has anybody ever heard of Selenium RC? Yeah, that's the oldie but goodie. That was the first iteration of Selenium based entirely in JavaScript. Google switched that from RC to Selenium 2 WebDriver, which used a lot of the WebDriver binaries that allowed it to talk directly to browsers. The short version is that it took Google, I think, 8 months to fix that problem because they never wrapped any of the calls that they used with Selenium RC, so they had to replace each individual one. I think it was like 80 engineers. It took 8 months to fully replace all of them, which is why you always want to wrap the library so you can quickly change out whatever things you do. You also want to have good reporting, which I'll talk to in a bit more, and obviously logging, because if a test fails, you want to know why it failed. Is it a test failure or is it a system failure? Tests have some basic rules around them. You want your tests to be atomic. You want them to be nice, short, and sweet. Only because I know everybody here loves standing in long lines and like sitting in traffic forever. Nobody does. Everybody likes things fast. Faster test runs also means that you get the results faster. When you get the results faster, you can stay on task that you're working on. How many people have ever worked on debugging a particular test that takes too long, and then you move off and you do 20 other things and you come back like, wait, where was I on that last one? I think most of us have in here. Yep, that's why you want them to be fast, so you can figure out what's going on quickly and get on to the next thing that you need to focus on. You also want your tests to be independent of each other, only because if you run your tests to be very dependent upon each other, essentially the tests are setting the system state to be correct before the test can be executed. In terms of the user has to do everything correct before they even get to that aspect, and it will work for them. Users are not like that. They will do everything wrong. Therefore, you want your tests to set up all the test data themselves, do the execution, and then move out. That way you can run any test that you want at any point in time. Another example of this is if you have kids, at some point you probably want them to move out of the house and be independent and not dependent upon you. That's why you want them out. Next up, you also want to be deterministic. If a test fails, you want to know why it failed and what caused it fairly quickly. This could either be because of the test itself failed, like the system is not working as intended, or it could be because of something else that occurred, like an API to login is not working, therefore you can't submit home loans, for example, or submit new healthcare information. Yeah, that's not good, but we need to know that the login service isn't working. So you always want your test to be expressive in what went wrong when it went wrong. You also want your test to be scalable right from the start, and that's only because when you try to do it later, it never works. An example of that is that you typically, when you're doing all the tests locally and you don't have to worry about parallelization, you won't find as many collisions. When you start scaling up, you run into many more test data collisions. And then you have to start working around it. When you just do it from the start, it's much easier. Object-oriented programming, everybody uses it, loves it. Think about more than beyond just page actions, think of them more as user interactions. It definitely helps that when you write out tests where you can just say log in as this user object, which actually goes to my next point, encapsulation, which is where you want to pass around entire objects worth of things. So a user object or a client object or airline. So I guess like passenger info, but essentially like a user. I'm trying to think of storage units. Storage units. Okay. So that would still be like user information, user profiles that you just pass around for it, and you can validate against it very quickly instead of setting up a bunch of different parameters that you always have to be involved with and watching. And that's only because when you start writing the methods with like 20 parameters, you get lost like halfway through the parameters list. I know I do. It's like, okay, I don't know why am I filling out 20 different fields. An acronym I use is MVO. It's essentially a minimum viable object. Whenever I create a new object for my test, such as a user, new user, parentheses, nothing else associated with it, the object itself is created with all the necessary info: username, password, birth date, email address, first name, last name, et cetera, et cetera, et cetera. Everything that I would need for any particular test. And then if I need to change a particular value for that, let's say it's for healthcare and I need to validate that they live in Utah, for example. Make sure that they have a Utah zip code. there we go. Or if it was a job searching application, filter out everybody applying from Colorado. You know, create a new user, zip code, not a Colorado zip code or whatever. And that's only because I do not want to spend any time when I'm writing a test out to specify all the different values. Like, do I necessarily care about what the username is going to be if I'm just filtering out Colorado? No. So create an object. The default object has everything built into it. Bonus points if you dump all that information somewhere. Obviously, test logs would be a good spot to do it. I typically also set up an Elasticsearch server to dump any objects I create into, so I can always reference it back later in case I find weird errors. One of the biggest ones I found was working at the advertising company. We were about to launch into Russia, and our system supposedly supported ISO characters, which should take everything. But for whatever reason, there was a query somewhere buried deep that turned it to ANSI. So no Russian characters were allowed, no Cyrillic characters were allowed in our system. And it was like, this would be suboptimal for ads in Russia if they can't use Cyrillic characters. And that was all caught because I just was like, yeah, just throw characters at it, I don't care. Technically, the string that caught it had a Greek character, an Arabic, and then a Russian character. And it was like, oh, that failed. I was like, oh, okay, why did it fail? And then, figured it out. But that's the point of it. I didn't have to create one for each single language. I was just like, generate a bunch of data. I do not care. Try it out, see what happens. For different usernames in that particular instance. I then use setters just to specify the actual point that I care about for the particular test. Next up is you want to start optimizing your tests because there's a lot of optimizations you can do. Overall, they go into 3 different categories: actions, executions, and maintainability. So any network calls always add up. I've seen a lot of Selenium frameworks that check for element visibility. If the element is visible, is the element clickable? Is it interactable? Is it whatever? It doesn't matter. All the different checks possible before they interact with it. Locally, of course, the test runs instantaneously. Total test time took seconds. Running it on their local Selenium grid takes 5 minutes, which was, we'll go with suboptimal. That's the word we'll use here. Every single one of those calls has to be made, and in doing so, going over their really slow network and through their horrendous firewall that they had set up. I say it was horrendous because that slowed down everything tremendously. It was amazing. It turned that same test that went in 5 seconds to, I think it was 5 minutes and change, just to log in. Like, we didn't even get to the rest of the test. I just got tired of waiting at that point. So you always want to try to interact with the element first and then deal with whatever you can afterwards. I also like to use explicit waits on stuff that I know takes a little bit longer. That's all there is to it. Fluent waits if you have to customize the polling period. Execution, use APIs wherever you can. It makes your life easier. If you don't, I'm stealing this tip from Carlos, make your own. There's a few different libraries you can use to help you make DB calls real quick and then just pull them into your system. So you can do the DB check to make sure that user is properly loaded into the system instead of writing in the test code polling for waiting for it. You can just have a call that just says, tell me when it's ready. In terms of maintenance, stick with a single tactic for all of your locator strategies, for all your locators. So with Selenium and even the other ones, there's always a way to specify what tactic you use by ID, by class name, by CSS selector, by XPath, by link text, partial link text. I'm sure I'm missing a few, tag, whatever. There's a whole bunch. I have a giant article that I'm about to publish probably later today that goes into way more detail on this. The short version for you all is that if you stick to one tactic for all of your automation, it makes it much more easier to maintain and train new people on it, instead of having to teach them, okay, well in this case you want to use by.id or by.tagname or by.css. You just stick to one and it makes everybody's life easier. The bonus points is if you use CSS selectors or XPath, because you can evaluate all of those on the console line of Chrome, Firefox, IE, doesn't matter, choose your pick, you can evaluate them in the console. So typically it's $ is a single selector, double $ matches all, $X is evaluate XPath. And if those don't work, you can always run that bottom line there, import jQuery into the page, and then it gives you that shorthand notation for. Now we're ready to supercharge everything. Sounds good? We're going to talk about all of that stuff in a very short period of time. So obviously all of your successful tests, if you have a really good reporting framework set up or use, Allure, Extent, Spec Flow, those are all solid ones. There's more. I didn't try to name all of them because I would just spend way too long time researching them all. I personally use Allure only because I program in multiple languages and I can use Allure in all the languages. That is it. It's a great way to onboard new employees. You can showcase how features are supposed to work or how they are working currently. You can easily pass it off to developers as well. When stuff fails, you can show them, these are all the things that are supposed to be interacted with. It didn't do this one bit here. Instead of just saying that a test failed, it's much easier to literally show them everything that went wrong. Performance testing, everybody loves performance, right? Does everybody know about Core Web Vitals from Google? Short version is Core Web Vitals is how Google's going to start ranking search engine results. So you have to have the higher your Web Vitals core score, whatever it's called, the higher it up it is, the better in search results you're going to go. That technically goes live next month, technically. It's going to take a while before it actually starts really affecting all the search results. In terms of QA, though, you would want to run this stuff on public-facing websites that people will do searches for to get to your product, your service, your company. Only because it doesn't really do well behind password-protected stuff, and 2, search engines don't check behind password-protected stuff. Add an argument remote debugging port, that's so that Lighthouse that can connect to the ongoing session. Do whatever actions you need to do to get to your web page, or this I'm just navigating directly to it. And then you run Lighthouse, pass in the URL, which you can just grab from the string there, port, and then output as a JSON, and then it gets you the whole JSON output, which you can then prettify and make all sorts of fancy stuff with it. Important part is you can start monitoring how is your Core Web Vitals score going on your public-facing web pages. By really only having that line in somewhere in your test code. Visual testing, has anybody ever dealt with or tried their hands at visual testing? There's a lot of promise there because it makes a lot of testing and checking very easy because it just checks to make sure that the page matches the previous baseline of the page. Which is great if your pages are very simple in nature. As soon as they get more complex, you start getting a lot more failures that crop up. So any of the larger pages that can have a lot of dynamic data in it, I would recommend that you use visual testing based on the CSS that is being loaded onto the page and make sure elements are being used with the right CSS, styles, weights, sizes, that sort of deal. If you're trying to validate data with pictures, it's going to cause more problems than it's worth. Just trust me on that little bit there. Unless you know for certain that the exact same values are going to be outputted every single time. Dashboards for advertiser data, not so much. If you need to check any of those values, use APIs to validate the values instead. Everybody does a lot of accessibility testing, correct? Yeah. Right? No, not as much as you would like. It's kind of hard. Well, DQ makes a product called Axe, which is a way to do accessibility testing. They have packages for Java, Python, JavaScript, I think, as of now. Doesn't matter. The highlighted lines are how you use their product, the packages that they have released. I'm a massive nerd. I will admit that freely, willingly, gladly. Here's the two main lines you need to use. You can, in your code, you can easily inject driver execute script import the agnostic Axe, which will insert the JavaScript, which is the same thing that the previous thing is doing. And then you can run the JavaScript on that page and it will return all the accessibility errors you could ever want to know about on the page. With that, you will have to go through it because there are some things that you still have to manually check for accessibility testing, such as alt attributes for images, because technically Axe can only check to make sure that you have alt attributes for the images, not necessarily that they're good. So you literally could put alt, this is an image caption, regardless of whatever image is, and that technically passes the check, but it's a fairly useless caption. So that's not really good for accessibility. How many people have environments where you can't do specific actions in? The short version is that you have prod, you make an enum of all the different environments. Prod is 0, always 0, because then you can have an infinite number of development environments or lower environments, it doesn't matter. Depending upon your test framework and the programming language and the test, mainly the test library that you're using, testng, JUnit, NUnit, whatever. It varies about how it does it, how you do that bit. But each test gets a certain priority of essentially how high is it allowed to run, right? So destructive tests can only be done in developer environments. Okay, have it set to like 20, value of 20 of some sort. And then if the tests are running in an environment higher than 20, ignore everything else below it. Custom errors. This is always a great way if you have to work with third-party services or mainly third-party environments that you don't have full control over and you just need to know if their service is down or not, just throw custom errors up. So you can quickly look through your test results and see, oh, we got 20 ad service errors. That means our ad service is down. Now at that point in time you can determine if that matters or not for the purposes of what you're doing. If you're just checking a brand new feature that was released and you're testing against like the lowest of the low ad service APIs, you might not care. You might care if it gets up to a higher level. But at that moment in time, you can then determine, okay, we can ignore these. But custom errors help you quickly find all the different issues. So component testing allows you to start unit testing the individual components. This is stuff more that your developers will be doing to a degree. You can leverage it to do more actions upon it to make sure it interacts with the way it's supposed to be interacted with like per device. Make sure that the components are scaling or, well, yeah, scaling down for mobile devices or not. You can validate that error messages pop up the way they're supposed to pop up, et cetera, so that when you go to the full end-to-end suite, you don't have to check every last error message on the web page. If it works in the component the way it's supposed to work on all the breakpoints, you don't necessarily need to do all of them. That being said, they are good to run feel-good tests. Awesome. I look forward to meeting with you and talking with you later.